Labs and with another Romanian company, Cashflow. And we work, just a snapshot, we do develop very advanced training simulations, and also we are now developing the first eye tracking system, which allows playback heat maps and all of those things. So this is something very new, and we're very thrilled to work on this. Now I'm going to formulate a problem, which is why is now the best time to build such tools for VR, for computer-aided conceptual design for architecture purposes. And I think this is a very interesting topic, because now we do have the VR solutions that support complex and, let's say, interesting interactive simulations which have come out of the labs, the research labs, and now are available for the general public. I think they're also financially affordable. So we are talking now about the first generation of affordable VR solutions, which I think are crucial in mass adoption of these kind of tools. Now also, because of that, we have the hardware, which has progressed a lot, and the software. So now we have GPUs and CPUs which are much more powerful, and they also support this kind of technologies, which I think is crucial. Now, on the other hand, game engines, which is something that I've looked into recently, have now the capabilities to display a large amount of data, and also they can do it with realistic materials and with realistic lighting, which is also crucial for the conceptual phase, because you need to see the results as fast as possible. And now, this is also very important, we have the procedural tools that can now interact and interlink with these game engines. And this is one of the main ideas and one of the research areas that I looked into very closely. I was exploring it as a master program in the Netherlands, in game technologies. How can you link the beautiful and powerful visualization capabilities of game engines and the UI aspects with a very powerful procedural backend, which allows you to create complex things, but also have them visualized beautifully and almost instantaneously. And first of all, I think there is a constant need of more intuitive yet complex design tools, because as the exploration space becomes wider, as we want to design more complex, let's say, projects, we need tools that can match our way of thinking. So, and we don't need to go always low level. So this is something that I'm going to explain in the following slides. I have some key concepts, of course a lot of ideas, but I want you to just remember one, which is actually the key core. Yeah, this is more or less, which I think is the main point of my presentation, that VR and procedurals work really well together, and they allow the creation of some amazing tools. Which I think this is what I'm trying to prove through this. In order to do so, I built a prototype, which is actually using a game engine, in this case it's Unity, in collaboration with a very I think the most powerful procedural modeling tool from the movie and the gaming industry, and via Houdini engine, which is let's say an extension allowing two-way communication between the two. You can actually have, on the one hand, you actually exploit the usability, the interactivity and the experience for the user in the gaming environment, and you combine that with the proceduralism, computation and complexity. And the first two elements are being, let's say, facilitated by the engine, the engine, and VR takes care of the complex experience, which is really important for this kind of explorations. And an overview of the concept is the idea of having, and this is the main contribution of having a game engine front end, and then a very powerful procedural backend. Of course, the two are communicating via custom Houdini engine implementation, which supports much more. We develop a version which is multi-threaded, allows much more complex data communication between the two. On the game engine side, we are handling UI, UX, we are handling the VR aspect, the lighting, of course, the lifelike materials and the environment. And on the procedural backend, we do handle the high-level conceptual parametric entities, which are one of the main contributions of this paper, and of course all of the import and export operations. And also important the data flow of custom attributes, which I'll explain in a moment. So this is more or less the research is based on creating the virtual reality prototype, which has this kind of high-level parametric conceptual design entities, which I'm introducing as a novelty in a way, because I'm moving away from the low-level, let's say, primitive or point or mesh-based approaches, or even to the more complex procedural methods, to something which is much higher. It's higher in complexity and it's higher in the amount of information that can be processed and worked through. And I'll explain that in a moment. Another component of the method that I use is developing the new user experience and user interactions required for such tools. And of course, this is also handled via this two-way communication. Now, these entities, these high-level procedural entities, they have what I call smart effectors. They have the smart presets, which I'll elaborate in a moment, and they have the geometric attributes, which are flowed through the system. And for the user experiences, we have some ideas. I have some ideas that I developed. Then again, I will detail in a moment. So one of the main contributions of this work is the creation of this high-level procedural conceptual design entity, which is based on a kernel which is coming from the procedural modeling engine, which in this case is marked red. And then it adds control parameters and effectors input and geometric input. To these inputs, we have a set of different smart effectors, which can be points, curves, surfaces, or volumes, which can be plugged and connected. And we have a list of presets that can be used. Now, the idea of using the presets is that sometimes it's very difficult for architects or designers to know the inner workings of a very complex computational geometric algorithm. However, if you give them, let's say, the results, and if they can visualize the result of that exploration, then they can understand what can they use it for without having to go into the inner workings, which is the idea of using the smart presets. And then the input geometry, which is being transformed by the entity, and then the output geometry, has also a very interesting, this idea of the whole entity was inspired by Professor Sorba's early work of the nucleus concept. I try to apply it in this, let's say, more realistic context. I'm still missing the physics simulation, and this is one of the parts that will be extended. But this is the idea that you get attributes which are flowing through the system. The entity processes some input attributes, or it can create those attributes, and they flow through the entity, and then they go out. And this can actually be chained, and you can create a very interesting result. I'm showing here on the Houdini end, on the back end, how such a high-level procedural entity can be created, and what you see there is the interaction of a volumetric effector, and how it can affect, for example, a parametric facade in this case, and how it can be worked. And you'll see soon in the results section how this will be used inside the VR environment. So this is just an example of this. This is how the system can be chained together and create a very powerful procedural flow, which starts with the game engine, goes through the procedural backend, and then returns to the game engine with the results, and it's a two-way communication. This is another example of such a high-level procedural entity, which is also based on a Shuko parametric facade system. So the idea, one of my idea was to include vendors' products in the design phase, so that we have, for example, Shuko in this case, they just launched their parametric facade system. And now including this has benefits, because then you can estimate costs, you can see a lot of, and you're working with the real-life, let's say, models. This is, again, a very brief explanation of how a process like this works. So this is very important to see that by data chaining this kind of entities, you can create very complex design very fast. And here, for example, we have the Shuko parametric facade element, which is actually one of the presets. Of course, you can choose from other vendors, other presets. There will be a lot of presets for the facade elements, for the geometric, for all of the operations that are being done can be made as presets, which is amazing, because then you can just combine elements and then bring your own contributions. However, it's also possible to go low level. Here I'm just giving some examples of some exploration which have been done, you'll see in a matter of seconds, not even minutes, which is, I think, something very useful when you want to explore more ideas. Of course, we'll discuss the limitations of the system also. One of the elements that we needed to approach when we work in VR is how do we interact with the fact that it's amazing that we have the scale. That's one of the main advantages, that you can design and you see the building or the entity full size. However, how do you do to actually operate on the whole complexity? Because you don't see only a part of the building. So in order to answer this question, what we were proposing is this model, which is called a scale model entity, which is able in VR. The video is playing. Should be playing now. These are, by the way, footages directly from the VR environment, live. And you can actually use this three-dimensional entity to actually operate. You can see dynamic cross sections and everything, so that you can actually model, and the changes you apply on this scale model are being directly reflected in the life-size building. So this is again one of the contributions in the sense that I try to answer the question: how can designer easily interact, and they can change the shape, and you can see the buildings, and you can select one building. Then the scale model will be you can change different parameters for that, and then you get. For example, now I've changed the building, so now I'm exploring the building, the big building which you see next to it. Okay, so I think this is one of the main issues that we need to solve, how to find new UI types for this kind of interaction. Of course, this works also for urban scale. So this is a very short example of part of a city of Breda, which has been using the high-level procedural entity to create the geometry, which is being created live from OpenStreetMap data. And then you can also operate, and then you can include and combine urban and architectural elements in the environment. Skip a little bit. Also for this, I had to develop the equivalent in VR of some of the UIs used by the procedural modeler. So here it's an example of a curve, complex curve model, and then you see the gradient. And also, directly in the VR environment, I also created this node-based editing system, which is very similar to the procedural tool in workings, with the advantage that it allows to combine high-level entities and low-level entities. So if you want, this is the solution when you want to go deeper. If you want to create something which is not yet created as a high-level conceptual design entity, you can go and mix those elements together. So what you see in the back, actually the result in the back, which is just a random example, has been actually created by evaluating the logical schema on the screen. And this can all be done directly in the VR environment also. I'll show you also now how this looks, more or less a little bit of the UI. So you have this kind of dashboard, control panel, from which you can select, you have world, material settings, environments, lots of entities which are required for being able to create these complex entities. Of course, the menu, the scenes, whatnot. And then you see, for example, here, how the material library works in a VR environment. So now you can actually touch materials, you can approach a library that you can explore, but you can also physically grab the material, you can explore it, you can work with it, and I think these are all interesting things. So again, the visual aspect was crucial because designers love to interact with their designs and with their materials and all. So I think this is something that has relevance. Also, the system supports time-of-day simulation and weather simulation, which can be also useful. In the Netherlands, for example, where I have my master, the sky is not always sunny, or actually most of the time is not. So this is important to see how your buildings and everything are going to look. And also, I wanted to look at the level of realism for real-time graphics. I'm using a voxel-based GI solution, which creates pretty, let's say, decent results in real time in the end. You'll see this. I'll just skip a little bit ahead, probably just to show the night mode also, and the fact that you can control time of day and all of that, and also the cloud cover, which I think, again, for the specific design problems might be relevant or interesting to see exactly how this can look in a different environment. And also based on that, I'm going to show you how this works in VR. So this is a live demo, or recorded live demo of such a complex entity, which combines the shape finding module with parametric pattern distribution element. And then you can see that in the VR environment, and here the recording is done before we implemented the multi-threaded stuff, so there will be some stutters, but in a normal, the latest version it works perfectly. We just finished it a few days ago. And the idea is that you can now control a lot of aspects, and you can combine those elements together. You get all of the elements that you see actually in the scene have been created directly in the environment, using either this kind of simpler exploration at first, because we wanted to find the shape, we wanted to explore the potential of the formal exploration, and then you can go deeper and deeper, adding more realistic materials, facade elements, more complex elements inside. And the advantage of this is that it always connects live with the very, very powerful procedural backend, which powers and empowers this kind of tool. Okay. One other aspect, I'm going to show you now one of the results. This is a workshop that I have done with students in the Netherlands, in Gran, and they were getting students, future students. They created, each of them created one of these buildings, and one of them created the environment, the city, actually two of them. And these were all modeled and created directly in the VR environment. We do have a multi-user mode, which at the moment is limited to one designer being able to create one entity, while the others are just spectators for that building, so they cannot multiply create yet the same building. However, they can create the same environment, so in this case, this was the application. What you see here is real-time render, so again, no pre-rendering, everything you see is live from the system itself, which I think is also something really cool, because you get this level of realism in real-time in VR, which is also one of the challenges that we had to overcome in developing the tool. But again, I think the results are pretty cool. I'm going to show you another example of how these elements can be used to create a very complex facade pattern for, let's say, an art museum. This is also a formal exploration and a pattern exploration of the facade. Yeah, so you see here that by combining, again, entities of the system, again, it's a little bit processing times are still very impressive for live connection with the procedural backend, but this is also solved. And you can see now that the designer can actually play, and I'll skip a little bit, just to illustrate some of the things that can be done within the system. You see now that I'm exploring another form of exploration. Yeah, okay. To version a bit. You just see that using the effectors, I'm just going to show that at the point, you see the point moving, and that's the effector, and you see how the pattern responds to that change. So that's one of the interesting results. Yeah, there are a lot of applications for Philips and Eindhoven. I'll just skip a little bit through. We used this system to actually simulate lighting in the cities, and yeah, so it was. We did a lot of research with them. I'll just skip to the conclusions and the distinctive benefits. I'll just put them all on display because I think they're important. This tool can be a potential time money saver. It can help with multiple conceptual exploration within a shorter amount of time. You can explore more. You are immersed in the space, so you see better the details of the scale. You have the scale model entity concept, which helps you with that. And then I consider it to be first of its kind in the sense of using this kind of combination with this kind of technology. Of course, exploration has to be made on this front. And then, on the other hand, I think complexity becomes more accessible. I do believe that introduces a high-level paradigm can actually be one of the keystones of building more advanced tools in the future. I think it also circumvents the algorithmic knowledge prerequisites for designers, which don't have to know how things are implemented, but how to use them. It has a powerful computational backend and a flexible modular approach. And on the critique side, let's say, for the limitation in the future, just very briefly, also providing some solutions. It's not a completely general-purpose conceptual tool yet. It implies a new, maybe unfamiliar UIs, which hopefully will be adopted very fast, but it's still new. Some of the operations are still lengthy. If you daisy chain a lot of entities together, it will still take a while. There are some multi-user environment limitations that I mentioned about being able to edit things at once. It's now limited to a Houdini backend, but I'm looking into adding a Grasshopper or a Dynamo backend as they become more powerful as required for the real-time interaction. No physical-based simulation yet. However, the procedural backend supports very advanced physical simulations, so I can integrate finite element modeling, fluid simulations, and all of that in the system. It's just a matter of doing that. I haven't tested it on a wide range, so it's not yet academically proven. The results are more or less empirical from this point of view. The sample size is very small. And I think one of the main developments will be, which I'm trying to pursue as a PhD, is to complement the designer's intuition and anticipate his intent using AI. And of course, we can use even brain computing interfaces. So this is something that I'm looking to explore in a future PhD. So, thank you very much. I tried to.